This conference will now be recorded.
Yeah. Yeah, so yesterday we were trying to understand the traditional approaches, like, so we have the waterfall approach in the projects, like, but this waterfall approach is having that some gaps between the requirements teams, the developments, the teams, and as well as testing teams, and as well as operation teams. So in this the projects to overcome those problems. So what is the main this the latest methodology which we are using this in the infrastructure, that is Agile. But by introducing this Agile is helping that to overcome this the gaps, especially between that the requirements teams, the development teams, and the testing teams. So this helping this the more advantage and having the more satisfaction of this the customers, like the projects releasing dates and delivery point of view, cost point of view, the satisfaction point of view. So we have the 459% better than this the traditional approaches, like which we have this the waterfall approach. So by introducing Agile is giving the more advantage to the projects. But Agile, with that Agile, what is the point we have this is we were trying to understand some points, like we have the sprints which are coming into this the picture, like to release the changes to the production environment, like more sprints they are planning about it with the small durations. Because of these sprints, like between the teams, it is making the more like the effort or the more work between the teams, that is more stress on the teams. Like developers, they need to work on this their activities, and they need to involve in the meetings, and they need to change that the next activities like which are suggested by the customers, and then they need to plan for this, like a release dates approaching about it, and in that approach they need to integrate their code with the other developers, and they need, I mean, say they have this a lot of work to complete it within the small duration of the work. So this is making the most stress on the developers point of view, and as well as these releases are making the more stress on the testing team, as well as like more releases, more times they need to go for this, like a test cases execution, test cases evaluation. So that is a more stress on this the testing team. And whenever we have the more releases, like the operational teams are having the more like work, the I mean the changes which we are releasing, which we are receiving, that they need to keep on deploying this to the infrastructure. So there's like we have the more environments, like the development environment, staging environments, UAT environments, performance testing environments, and then like the live environment. So the infrastructure team, they need to make sure this, so in all these environments, whatever the change which is coming from the developers, they need to apply it, and they need to make sure that the infrastructure is ready for the testing teams, and as well as UAT teams, and as well as production teams. So more work between this the developers, testers, and operation teams. But finally what's happening this is, so this is everything is performing that they are performing that the manual approaches. So that's manual approach which is making this the communication gaps. So but because of, I mean, these communication gaps are making that infrastructure related issues. So before, like I mean, the waterfall approach was making this the communication gaps between the requirements, developers, and the testing teams. So to overcome that, so which we have this the agile approaches, but this agile approach which is making the more releases, more sprints, so which is having the more work for this the development teams, testing teams, and operation teams. But everything they are doing that the manually. But to overcome these manual gaps, so how does the DevOps is going to help in that? Especially we were trying to understand that, like the gaps, I mean the gaps which are happening thus the infrastructure level. So why we have the infrastructure level is the development systems are the completely different, where the developers are going to use it to implement their application. But whereas the infrastructure teams which they are setting this for the application is entirely different. They use the high secured environment and high protected environments, are like which we can say this the multiple systems, and with the failovers, the scalability features, the load balancing features. So operation team's objective is different, and the developer's objective is different, and the testing team's objective is different. So these objectives which are making that, so there's a like impacting on this the project releases to this the production environment, so which impacts the revenues, the dependent plans and the support activities, which is impacting on the revenue of this, and integrity issues like impacts reliability. So they're all happening thus, so which we have this the communication gaps between the developers, testers and operation teams. But all these teams coordination work which is going to helping that to coordinate it all the teams work, that is the DevOps. So there are the points which we were understanding yesterday, that is developers, the testers work and operations work, coordinating all the teams. Yes, we have this the DevOps process. So we are concluding about it, DevOps is the not the tool, so DevOps is the process which is helping that to have the better communications between the developers, testers and operation teams. So finally, so what is the DevOps? This is the definition we were trying to understand. So better communications, the collaborations and integration between the developers, the testing teams and professional like operation teams. So whenever we use it operation teams, so just think it about like the administrators who are working in the live environments, like the network administrators, the system administrators, middleware administrators, database administrators. So they're all the teams. I mean, the so many teams for the different tools they are working that, but project is only one. But all these teams work coordination is very very important. Whenever we have the more releases to the production, so different tools are having this in the infrastructures and who are supporting by the different administrators, and all this the operation teams, the developers work and the testing teams work, the coordination is very very important whenever we have the release plan to the live environment. So how you are making before everything manually, so once there's the development is ready, then okay the testing phase, so which they are taking this some more time. Okay, so what are the changes that we got it from the developers applying to the testing team, testing environment. Okay, noting this all these like what we have done the change, so noting this all this the plans which we have this, or what are the activities which they have done in staging environment, then taking this plan and applying this in UAT. And if the UAT is successful, then noting about this all the plans, the activities which they have done and the backup plans and applying this to the production environment. So a lot of time is required. And yeah, so there's a main the principles of the DevOps which we have this is, so have thus development and test in an environment similar to production. So we were trying to understand this. The first one of the point is the developers they are going to use it Windows systems and application is going to run on this the different systems. Because of these different infrastructures which are making the some more infrastructure related issues. So these infrastructure related issues which are happening thus on the project, which are having the impact on that the project delivery dates. But the DevOps, what is the solution that is giving is why you are using the development infrastructure separate and why you are using the like a production environment separate. If you are able to make it thus the same identical environment, yes. So we don't face that the infrastructure related issues. So between the environments, that is one of the principle which we have. And second, if we just try to understand that, so this DevOps is helping about it what of the change which is identified, that means the builds which are ready, so there's like a frequently releasing these builds to the production environment. Yeah, we have the solutions for that. So how you are going to release about your current change from the development environment to the production environment. So that is the main objective of this the DevOps, which is helping fast release of that change to the production environment. And the next point we have this is the validate operation, the quality continuous. I mean, whenever we are releasing the particular change from the development environment to the production without the quality verifying, we should not release it. Or the DevOps is having the solution. How do we go ahead continuously monitoring about or continuously testing about our the validating this the testing as well as, yeah. So there are some principles which are helping. So finally the DevOps point of view which we're trying to understand is the continuous deployment and continuous testing. That means once a developer he says my code is ready, okay, so take this code and run this code in the testing environment, and So the testing, all the test cases executed, and then go for this deploying the same application to this next environment, that is UAT environment, and then run the test cases of that UAT. And if it is successful, then take this application and deploy in production environment and run the production test cases. So this is the continuous activity which is happening that, and this the continuous delivery activity. So DevOps has come up with the continuous delivery activity. So deploy it and test it, deploy it and test it. So, but what are the environments? Yes, testing environment or staging environments. So UAT environments, performance testing environment, production environment. So this is the continuous delivery which is coming that. And finally, if we combine that Agile and DevOps, which is helping that to have this the continuous integration, that means any the requirement which is identified, prioritize it, design it, develop it, and then create that or convert into this like the build format, that is .exe file format or the .bin file format, and then deploy it and test it. And once this is testing confirmed, then take this the change which is confirmed in the development environment and deploy in this the next staging environment and test it. Next, deploy this in UAT environment and test it. Next, deploy this in the production environment and test it. So these are all the two main points which are having this or which are coming into the picture, like whenever they introduce Agile process. So they are coming that Agile process and as well as DevOps process. So DevOps is helping the continuous delivery of the change, and Agile is helping that the continuous the integration point of view of the change. Yeah, the finally we are trying to understand this the continuous integration as a continuous delivery, and this which is helping about it like as the once the change is ready in this the development environment, so there's the you should able to deliver the change as fastly as to this production environment. So with the feedback says something is happened that yes, go for this evaluating about it. So what's happened, why it's happened, so what is the better approach which we can go for that. If it is a manual activity, is there any solution to automate it? So this is the kind of the approach which are coming into that and which are making thus the continuous integration as a continuous delivery. Yeah, these are the points that we understood yesterday already, and anyone is joined today, so just like the understand this, so what we had the concept yesterday, that was just revision which we had it just now. And now let's continue that. So there's the what is the continuous integration. In this continuous integration, what are the main activities? So what are the main activities that's we are going to use it? That's the continuous integration activities, and then continuous delivery activities. Yes, we'll try to understand that. So this is differentiating the main activities point of view in the process. Yeah, so continuous integration is integrating. I mean, so there's suppose if we take the application, an application is handled the multiple components. Like yesterday, we were trying to understand that the Gmail application, which is having that login page is one component, or inbox is another component, like the spam or compose mail, or like a Google Doc integration or settings, which we are doing that. Everything, they're all the different components of that application. But all these components that's implemented by the different developers, all these like only one developer, he's not going to implement the complete application. So multiple developers on one component, and another developer, some other more developers on another component, like that. The group of the teams are working that in the development environment itself. That is the main point. This we are understanding this development environment. So this group of all the teams are working here, and finally objective is all each developer, what are the code he is implementing, which is required to integrate with us other developers, and multiple components, so which are required to integrate as a single application. But while integrating, what are the challenges they have? Suppose if I am one of the developer, if I am going to commit the code, my code is ready, and if I am going to integrate my code to that other developer, yes, I need to verify that some of the activities before updating my code to that other developers. How do we do that, or what are the activities? Yes, the main activities, if you just observe that, so whenever I am pushing the code in the sense, so once my code is, yeah, is it everyone is facing that any issues with my voice? Hello?
I am fine.
Yeah, yeah, anyone is facing the issue with my voice?
No.
Okay. Oh, good. Thank you. Thank you very much. Yeah. So, so the main first activity is push the code to the repository. What is this pushing the code to the repository? That means, so the point is, if I'm the developer, once I implemented my code in my local desktop or in my local system, so what are the desktop or the laptop which is given by the team, so the code I have implemented, everything is available in my local system. Once my functionality or the change is ready, I should not keep this in my in local repository. In my local system. So from my system, so I need to take it and I need to upload, or I need to push that code to that repository. Repository is like storage area, storage. So what are the code of the project, so which we are implementing? The entire code of this, all the developers code will be managed in centralized system. The centralized systems which we call this as repositories. Yes, once my code is ready, I need to push that code to the repository. That means I'm integrating my code with that other developer's code. That means the complete project code. But whenever I'm pushing that, yes, what are the things that's required to verify that? So the first is my code has to be reviewed. Code reviews required. That means I'm following that. If I'm the developer, am I following that all this the coding standards as it is suggested by the client or not? That is the code review or static analysis. We say that. Because to perform this code review, we don't need to compile it, we don't need to have the servers. So this is just like suppose if you just observe that the code review, some of the like the project client point of view, the program which they are implementing, that the file should not contain the more than the 200 lines. So there is like a coding standard. That means the file, it should contain the maximum 200 lines only. If that one of the developer by mistake he has implemented the code like something 210, that is violated. So it should not be accepted. So if he is going to try to push his code to the other developer's code, then it has to be verified and it has to be identified, boss, about the lines of the code is extended where we don't accept it. So please change it and revert it back. That means the commit back. So this kind of the evaluation is required, the report is required. So the code developer, multiple developers, but repository is one. But how do you verify this all these things? So whenever he is trying to push the code to the repository, yes, it is required to have the review of the code. Before, how they were doing that, everything manual. The team leader is coming in the picture and he is going to manually verify that and he is accepting the code, then which will be integrated with other developers code. But we have the solution for that as well as. So these are all the tools, yes, which will come back. And once his review is confirmed, then his functionality, whatever he has implemented, everything it is, whether the functionality from the developer's point of view, there's the basic functionality has to test it. That means unit test cases will call that. So that unit test cases required to execute it, that report has to be generated. And if all the unit test cases are successful, just accept this code to the integrations areas. Otherwise, don't accept it. So there is a pre-deployment testing or unit testing is the third phase we are expecting that. Next, what we are expecting is packaging and deploying this to the environment. Packaging in the sense like suppose project contain this thousands of the files. But all these files, we don't take it one by one to install on the server. So what we need to suppose, you are downloading that one of that application software for the Windows is nothing but we are downloading the .exe file. So .exe is the packaged file. That is the packaged one. That application complete software is packaged into the .exe file. So this is .exe which I am downloading, and if I double click, it is installing that all the application related files to something C colon program files. then you will have that all the files which are required to run that application. So packaging and deploying that to the testing environment is required, because it has to be verified his functionality. And then the post deployment testing or integration test cases required to run it. So that means after deploying this application to the server, so the test cases required to execute it. So that means, so what are the integration test cases we have? Suppose the one developer, he is working this on single component, but this component related code should not give us the impact on other components. So one component, second component, third component, all these components, the test cases required to execute it, to evaluate it. So his code has given that any impact to that other developer's code, other functionality of their application. So that is required to evaluate it, which we can say that integration test cases. So this is the complete process required. Like the developer, he should not have the code in local systems, and he should upload it to this repository. Once it is uploaded to the repository, yes, we are expecting that the code reviews, we are expecting that unit test case execution, and we are expecting the complete converting the application to that packaging and deploying models, and deploy this to the testing environment, this application. And once that is deployed, and run the test cases or integration test cases. So these are all the activities in the development environment we are expecting. That once my change is ready is nothing but they're all the activities I need to verify that. But manually verifying that, thinking about that in the sprint, we have the only that is a 2 weeks or the 1 week on the base of the practice. Within that 1 week, how I can integrate with that other developers code, how I can review my code, how I can test my unit test cases, how I can do that, like deploying that application to the servers, how I can do that integration test cases. With these activities itself, it is going to take it the more time if he is going to do that the manually. So that's process which is required to automate it. So this is the point. So this is the point which we are expecting that from the DevOps engineer. So developers, what are the continuous activities which they are doing that? But what are the continuous activities of the developer? Yes, code reviews they need to perform, unit test cases they need to execute it. But implementation is their activity where we cannot skip that. But once his code is, he says my code of the business logic is ready, then we need to go for that code review, we need to go for those unit test cases, deployment of those integration environments, and run the integration test cases. How you are going to do that? Automating this process, because this process is not only one time of the sprint. The sprints are coming into the picture, so for the changes, but these sprints, in that sprint we are expecting all these activities. They're all the daily activities. This is the continuous integration. How do we have the solution for this, or what is the solution that we have for that? Yeah, that is the main point which we need to think of as DevOps engineers. Yeah, this is the continuous integration. But once this integration testing is ready, then this is required to deploy in the remaining all the environment. That is also point, that is deployed, test it, deployed, test it. There's a continuous delivery which is coming that. Yeah, so the next point what we have is the delivery point of view, that is the taking that application and deploying this to this remaining all the environments and testing about it. But how do you manage it? So here we try to understand that the sum of the process, so like with the diagram representation. So let's have this the points. So taking that each continuous integration build and run it through the deployment procedures on production or non-production environments. So once the integration build is ready, take it that and deploy this to the remaining all the non-production environments and finally to the production environments. But in that process, what we are expecting is get the code from the developers, build it, build just a simple understand that .exe file creation, or I have those 10 files, I need to create a zip file. How I can create a zip file? The 10 files I should not distribute it. I need to create that as a zip file. Then that is my packaging structure. But we'll come back. So in the Java GT, what are the types of packaging structures we have? We'll come back. But that's a process. The 10 files converting into the zip file, or 10 Java files converting into that one zip file. That's process we call as build. Build it, convert to the zip file, and take the zip file and deploy on the server, and then make sure that the servers are up and running, and then run the test cases and get the report. And if the report is successful, then go to the next environment, deploy it and run the test cases and get this report. And if the report is successful, then deploy this next environment and then run the test cases and take the test report. So this is the continuous delivery which we are expecting that. Yeah, but here the some points, I mean, which we will come back. I mean, we'll come back to this process. But just understand that get the code or the build it, binaries, deploy it, start the services, test suite, reporting. These are all the main activities we are expecting that. But how do we manage it? Yeah, let's understand the some points here. So developers from the computer, developers from his system, he has to push the code to that code repositories. So what is the tool that we need to configure in this process, continuous integration process? Source code repository is required to configure it. So developers, once his code is ready, he's going to upload the code to that one of the repository. So we have some source code repositories which are available in the market. So we need to configure that the source code repositories for this the development team purpose. Yeah, that is one thing, the source code repositories management. And the point what we have this is, once the developer is committing or pushing or check-in also, we'll call that on the basis of the tools, we have the terminologies, but don't worry. So here the developer, he pushes the code to the repository, then we are expecting about like code analysis, unit test case execution, and then like packaging and then deploying and then running the test cases. But how do you perform all these activities? Some person has to monitor it or not? Yes. So what do we do this is, so we have thus some tools in the market. So that is the continuous integration server. This is like as a watchman, and this is like as an integration tool. It is watching and it is going to perform that integrating all the activities as well as. So this is one of the tool which is available, which we can call this as CI servers in the market. So this CI server, what it will do this is, it will keep on monitoring this in the source code repository. That means we will integrate this CI server with this source code repository. By integrating, that's what's happening. So this is going to keep on monitoring that any developer push the code to this repository. That means he is trying to integrate his code to that other developers. Then immediately what it has to perform is, it has to start the working on that. That means get the code. That means to pull the code from the repository. Then what is that activity? Build it and take the binary, that is the .exe file or the .zip file, and then the deploy to the servers. So this is activity. But who is doing this, all these activities? Pulling the code, perform the build activities, performing this the deployment activities is CI servers which we can use it. And this CI server is going to helpful like to create that artifacts or binary of that application. And once binary is available, binary is like, suppose just assume that a .exe file or .zip files. But the zip files, we don't manage it in our local system or build servers. What we need to do this is, we need to upload these files to the repositories. Separate repositories will be used like to store that .exe files or .zip files. .exe is there is nothing but .exe related. The source code will be managed in the separate repository. So source code repositories, the code of that, and this code is required to convert and generating the complete .exe file, and .exe file will be stored in the separate repositories. Because suppose whenever you are downloading that any software, we will be handling the multiple versions of that software. That means each version, that version related source code and that version related .exe file. So .exe will be stored in the different location, that is separate repositories, which we'll call that artifact repository. And we have that source code of that .exe also parallelly will be having that will be stored in the separate repositories, that is source code repositories. But source code converting into that the binary file or artifact, so we need to perform some steps. But all these steps, who will do that? That is the code reviews or the unit test cases execution, and then compilation, errors identification, packaging. That packaging the .exe file is required to upload it. So this is the process we have that. So that is the tool which is helping that, all these activities to perform it. That is the tool which is helping the CI server. Yeah, once artifact is ready in the artifact repository, then what I can do is I can download it, that artifact, and I can deploy this to the testing environment. If the testing environment is successful, then I will download this artifact from the repository, then I will deploy this to the next environment and run the test cases, then deploy this to the next environment. So artifact creation process in the continuous integration, and once continuous integration is ready with the binary, then we can take it and we can deploy this to the remaining environments and run the test cases. So this test service environment, we need to deploy it, download it and deploy it, and make sure that the test cases are successful. If they're successful, so take it this artifact and deploy this in the next environment, that is UAT environment, and run the test cases. So this is the activity which we are expecting, so which has the continuous delivery point of view. That have understood these points, or anyone having this any queries? Yeah, just let me know that until to this. But next we are going to discuss some pipelines, then you will be having that's the more understanding on this, how that would be. Yeah, but to the point what we need to understand here is, so we need to have this for our projects to define this complete process. Source code repositories, we have the dependency. Build tools, we have that means converting or packaging about that application. So we are going to use it, some build tools. And we have the dependency on the code review tools. And we have the dependency in the process for the unit test cases executions and unit test cases report. And but all these activities, who is doing? As CI servers, we need to use it in the process, and artifact repository servers, we need to use it in the process, and we need to know about the servers, like to perform that deploying that application. That's a server's understanding, and running the test cases, and analyzing the reports, and reports are successful, yes, move to the next. So this is the process we are expecting. This process, to define it, we have the different tools for that. But what are those tools? We'll come back to this to understand it. But this is the process which we need to have the picture in our mind. Then only we can understand that, yes, which tool, which purpose. Yes, we use it like, we talked about the Jenkins or Ansible or Puppet or what about all these tools. Yes, in this process, there are all the tools which are helping that. Now, these tools, we will learn it, and we go for that. We are helping to the development teams, testing teams, and infrastructure teams. So that's the main point, or the main objective of the DevOps engineer. Yeah, so that's the point. So yeah, anyone having that any queries so far? Yeah, so now let's move to the next activity, like understanding that what are the main activities. Okay, we have seen that now we understood, okay, CI and CD operations. That means once change is important. Don't think that there is a application change or infrastructure change. Okay, don't worry about it. So we are expecting that. So client is confirmed that application related change or infrastructure. Yesterday we are trying to understand this in the design documents. We have the two types of the designs: system design and programming design. Programming design is program change, that is application change. But CI/CD process, you are going to talk it only application changes? No. The next which we are coming into, that is the infrastructure change also. That means the system design. That means 100 servers that is required. 100 servers, how you are going to set up for this application purpose. Today there is 100. As the business is good, but tomorrow maybe there is 50, as the business is going to get down, or maybe tomorrow there's a business once again very good, maybe required, there's a 50 servers required to 200 servers. This is also change. Today my application is required deploy on, suppose the Google team, they are planning that my application is required deploy on the 50 servers. That means the 50 machines, let's assume that. So how you are managing the 50 machines? But Gmail application is very good, so millions of the users are attracted with that, and they are trying to use it. Then more load on the 50 servers. then they need to go for that, applying that the change. What is the change here? 50 systems required to change it to that 100 systems because the heavy load in the live environment. Then how do they go for that, applying this change to the 100 systems? That is also change. So whenever we talked about the change of this, the client, that could be infrastructure change, or that could be like application related change, or the configuration change. These changes, how quickly you are delivering this to this, the production environment. Production environment is important. Development, testing, these are all like, yeah, the evaluation and implementation. These, without having these, yes, we don't have the production. The objective is end user satisfaction. End user, when he will get it, yes. So whenever the application performance is good, an application functionality is good, so then the end users, so they are going to attract it. Then more end users are attracted, then more load on the servers. More load is there, yes, go for extending the more systems or change the infrastructure. So this is CI/CD we are applying to the change which we are expecting from the clients. This is not for the only application change. So now we are going to understand this, the developers and operations activity. Yes, so we are going to become as DevOps engineer, but what are the main activities? If we just observe that, one of the activities, infrastructure automation. So as the infrastructure point of view, just what are the things that we need to remember is, yes, machines, virtual machines. Like today I have this one system, so I need to have the 10 systems tomorrow. 10 systems, how you are increasing. But whenever you are increasing the 10 systems, we need to think that the storages as well as how you are going to manage the storages. Today, for my application, 100 GB is required. Tomorrow, my application is expecting 200 GB is the storage required. Because the more reports or the more, or that could be in the terabytes or that could be in the pegabytes. We don't know that. What is the storage capacity required? But how you are increasing the storages or how you are going to decrease in the storages? Do we have any automation process, or can we apply the CI/CD process for this, like extending my storage or decreasing my storage? And the networks configurations, so internet, I mean the networks availability between the systems, so the proper communications and the high the capacity of the systems, the communications point of view. Yeah, this is also required to have the automations. That is the point, that's change. So these also changes which are required to have this through the CI/CD process. Yeah, we have the solutions, we'll come back, but just understand the points first. Next point is configuration management. Once the infrastructure has been set up, that means the storages or the networks or the number of machines and everything with operating systems, then you need to manage it about your platforms, right? The platforms, like if you're going to install this on these virtual machines about the Java application, then the Java platform is required. And if that application type is the .NET related, the platform you need to set up that, because the application is Java related, the Java softwares or the like servers required. The .NET related, the applications or servers, or the Python, that is going to have the Python installations on their systems. So if that my application, the PHP application, or the database systems. So so once the infrastructure is ready with the storages or the networks or the machines are like which we have the memories or the process or like which are coming to the storage or the disk drives, the sharing the files between all the systems. Yeah, there are all the points which are coming to that infrastructure. And once infrastructure is ready, then you are going to take this about your application and deployments. But the deploying that, if that application type is the Java software is required on the system, or if that database you are going to use it for that application, that database system is required. I mean the MySQL, if it is MySQL, you need to install that on the system. But installation is one time, okay, good. But suppose today I have this one configuration on my Java platform. That is, let's assume that Java 1.7 is installed. 100 systems, okay, in all the 100 systems, Java is installed with 1.7. Good. But tomorrow there is a Oracle system, they have released 1.8, which is having this advanced than 1.7 with the high performance and the high securities, which they have released the latest version 1.7 to 1.8. Then the client is decided, okay, go for that 1.7 changing to that 1.8. But this 1.8 on 100 machines you need to change it. 1.7 has to be changed to that 1.8. This is a change. This is a platform level change. Then how you are going to uninstall that 1.7 and how you are going to install this the 1.8 on all 100 systems? Because some of the systems which are the development, some of the systems like the testing environment, some of the systems like UAT, some of the systems are the production. In all the environments wherever the Java is there on the systems, 1.7 uninstall it and 1.8 install it. But how do you manage it, that change? Are you going to take this the 10 days or the 20 days or the 30 days? Because the client is asking the change and okay, we need to have this anytime. No. So this is not the new approach. This is the older approach. Yes, older approach, what they're doing is first, okay, you are asking that the 1.7 changing to the 1.8. Okay, we need to have the some specific time. Then they are going to ask this extra budget to manage the resources, extra hours calculations. Extra hours calculation is nothing but hourly calculated on the resources. Then extra cost to the customers. Okay, so that was the older approach, but what is the latest approach is? Okay, give that 1.7. Okay, so I will change that the 1.8 within that next 3 hours or the 4 hours. At least on testing environment. First, at least it is required to apply that on the testing, and they will evaluate all the test cases, then go for that, okay, applying to the production. But how fastly you are delivering that change to the production is important. Yeah, that is, I mean, these are all the continuous changes. This is not the one time. So suppose we have the ports changes, or we have this like the users changes in the system. Suppose one user is joined to the project. He is going to work on all these 100 systems. Now this user is required to add it in all the 100 systems with username and password. Otherwise he cannot log in. Then how do you add that this new user to those 100 systems? Or one user is leaving from the project. Then you need to remove that this user account from all the systems. Then how do you remove that all this user account? These are continuous changes. This is not that one time. These are continuous changes. These are all the configuration management, which we can call that. That is a infrastructure automation, configuration changes. Then next, which we have the deployment. That is application versions. These are all like the application related changes. So application keep on getting the developers which are coming into the picture, and more releases, more deployments. So once that infrastructure is ready on that platform, you need to manage it, and the platforms are ready, then you are deploying that about your applications on the top of that. These are all the three main services that we have: that infrastructure as a service, platform as a service, and application or software as a service. But how you are going to manage it, all the things? Or do you have the elite solutions as a fast delivery with the CI/CD approaches? Yeah, so these are all automation. Whenever we talk about automation point of view, like we need to write it to some scripts or not? Yes, the point what we have is infrastructure related. The scripts we need to go for implementing. Configuration changes to manage it, we need to go for that, the implementations. Deployments point of view, we need to go for the implementation of that. They're all automations. We're going to write it the CI/CD process. CI/CD process is not the manual process. Automation is what all the manual activities you are performing, that all these manual activities you need to implement one script. That script, instead of you, that script has to be executed. That is the point. That means you need to go for that as a DevOps engineer. You are going to become as one of the developer to write infrastructure automation code, or configuration management code, or deployment automation scripts. We are not the developers of the Java developer or the .NET developer or the Python developer or PHP or the SQL developer. No, we are not that developer. We are going to become as a developer to automate the process. In this process, infrastructure automations, or the configuration automations, or the deployment automations. So DevOps. So we are learning about the DevOps. So yes. So what is the section that we are going to become as a dev engineer is? So to automate that infrastructure configuration and deployment. And once these are automated, then we are going to become as operations engineer. Yes, what about that operations engineer? You need to go for that. If you have in this process which you have automated, If you have any issues, that issues has to be identified and issues has to be troubleshooted. That means the logs management and performance of this the complete process, how we have, and how we have this the monitoring. Like you have set up those everything 100 systems with the CI/CD process, but how you are monitoring about it, continuous monitoring, continuous like automations and the continuous integration, continuous deployments or continuous deliveries, continuous testing. So first to three sections, if you observe that infrastructure automation, configuration automation, and deployment automation, yes, to automate it, we need to have the some programming or scripting knowledge that is which is going to helpful to automate the infrastructures. And that script, once it is implemented, you need to keep on monitoring it and manage it with the troubleshooting activities and performance activities. You are going to become as a operations engineer. So what is that the meaning of the DevOps is development. Yes, we are going to write it as some automation scripts as a developer, and once that is automated the process, we are going to become as a operations engineer to monitor it or manage it or to track it. That's the complete activities of this infrastructure. But all you are going to become as a DevOps engineer to collaborate it, developers activities, testing team activities, and operational team activities. So we are going to become as a DevOps engineer to collaborate with all the teams. Yes, that is the meaning of the DevOps which is coming into the picture. Yeah, so that is, so thinking about that, how much value or the demand which we'll be having for about our activities point of view. Yeah, so anyone having the queries on this? Now we are coming back to that. Yes, in this process, what are the tools are supporting us to fulfill it, these automation activities on this, the infrastructure point of view, or the configuration management point of view, or the deployment point of view, or the monitoring, or the management. Yes. Any queries on this so far? Okay, good. So, so now let's try to understand this. In this CI/CD process, what are the different tools that is supporting that? Yeah, so let's have the words on these tools. Like a first tool is, yes, source code management. Yeah, we are understanding the source code management as like the developer, all the developers code is required to manage it in one of the central repository. Yeah, so source codes to manage it. So what are the different tools are available in the market? Yes, we have the subversion, that is SVN, we'll call that, the CVS, Gate, the Mercurial. So there are the different tools. But one of the best tool which we have this, the more distributed architecture which we have this is Git. We are going to learn it about this, the Git from the source code management tool. So this is one tool, so the Git. And the next is build tools. Like as we discussing that .exe file has to be created, or .g files required to create it, or in Java terminologies we have .jar files, .var files. Whenever we come back to the technology variant, we'll come back more. But the build tools are helping that to perform or to generate source codes into that binary files, that is .g files or the .exe files. But what are the build tools are available in the market? Yes, we have Ant, we have the Maven or the Gradle. So these are all like on the base of the technology which are available. So these are all supporting for the Java, and we have the .NET related its specific build tools, or the Python related the specific build tools, or the PHP. So on the base of the technology, this build tool is going to change it. So one of the build tool we are going to discuss this, that is the Maven, and this is that's advanced like other more features which we have to compare with in the open source tools point in the market. Like Maven is the the powerful build tool for the Java GT based applications. That's we are going to talk at that, the Maven from the build point of view. And code review tools, yes, the static analysis section. Once a developer he says my code is ready, the first and foremost activity is code review. But what are the tools that supporting that the reviews point of view is? We have the Sonar Cube, or we have the PMD, or the Checkstyle. So there are the different tools which are available in the market. So what we are going to talk at some of the points on this is Sonar, which we try to understand about that. How do we integrate in the process about the Sonar? So code review point of view, there's one of the tool. And yes, So once this the .exe file or .gif file is ready, this file required to upload into that repositories, artifact repository, source code repository, and artifact repository. So what are the different artifacts repositories, and which one we are going to discuss is we have this, the artifactory itself is one of the tool, Nexus, Archive, there are the different tools, and we are going to talk about the Nexus. So we try to use it about the Nexus to upload about our artifacts. We have those demonstrations which will come back on the Nexus point of view. And the next tool, one more tool what we have this is CI tools, like a continuous integration tools. So this is the main, I mean, if we just remember about our diagram, the CI server, so this is the tool. So which is going to helpful. So coordinating all these tools, like build tools, the source code repository tools, and artifact repository tools, and code review tool. That's why we say that integration tool. So pull the code from the source code. That means you need to integrate the CI server with the repository. Then integrate with SonarQube. Then integrate with like a Maven build tool. Then upload or integrate with the artifact repository to upload the artifact. Then it is required sometimes deploying this to the servers, though, so have that connection to this the servers as well as. So this is the main server, so the continuous integration server. But what is the tool that we are going to talk it in this continuous integration is, that is one of the powerful tool, that is the Jenkins. So we are going to talk it, but we have those other tools in the market like Hudson, TeamCity, Bamboo. So there are like some open source. Jenkins and Hudson are the open source, and the TeamCity, Bamboo are the licensed version. But Jenkins is that the 70 to 80% of the products which they are using the Jenkins. So we are going to discuss the Jenkins, and on the Jenkins itself we have this the 8 to 9 classes, or around 10 classes we have this on the Jenkins. And on this Nexus around one class, on this review tools point of view this one class, Maven point of view like 2 or 3 classes, and source code management Git we have the 6 classes on this, because this is one of the important integration point of view, code integrations. Yeah, so there are some tools so which are helping in the process. And the platforms, yes, we need to have this like understanding or working on those platforms, the Linux or the Windows. Yeah, Linux is, so which we are going to deal with the completely with the Linux. Yes, which we need to have the Linux understanding. And the management tools, yes, configuration management, as we were trying to understand that. So there's any platforms to set up, the Java platforms or the PHP or the Python or the .NET. So we need to use it some tools like 100 systems, how I can change my Java 1.7 to 1.8. So there are the configuration management tools, but what are the different tools are available in the market to handle the configuration management is Ansible, Chef, Puppet, udeploy, the Rundeck. There are the different tools. We are going to deal with that two tools here, Ansible and Puppet. So there are the two tools, and the Chef is that the older tool. So there's Ansible, which is supporting more the cloud infrastructures. The Ansible is which they are expecting more on this Ansible now. But we are going to deal with this, the Puppet also some classes on this. So Ansible around, we are going to deal with that 7 to 8 classes on the Ansible. This is, suppose I have this one GIF file. The GIF file I need to copy this 100 systems. How I can copy this one file to 100 systems? Or how I can apply the configuration change to the 100 systems. Yes, these tools are helping that. How do we distribute, or how do we run the commands on the remote systems, or how do you distribute about your application? So that is the, whenever we have this the question in the process, yes, we can, which we can use it. This is, these are all the configuration management tools. As we were trying to mention that we need to deploy application on the servers. So app servers we call that, application servers we'll call that. Yeah, we need to have that, the servers point of view, how I can start it, stop it, how I can deploy that application on the server, how I can check it that the logs files in case the deployment is got failed. Yeah, there are some points required understanding from the servers. Like we have the different servers, but we are going to deal with the Tomcat, almost 50% more than the Java JT infrastructure they are using the Tomcat. So this is one server is required to understand it. And yes, automation tools, test scripts to run it. Yeah, in the CD process, we need to run the test cases. But the test cases, how do we run it? We are going to implement it. No, we are not at all involved in this in the development side to implement the application, or we are not involved in this in the test cases implementation. But the test cases who are providing by the testing team, that is, they are using some tools. Those tools we need to integrate in our process, and we need to generate the report of the testing tools. That is a like we are we are helping to the testing team. But what are the test automation tools which are available in the market? Yeah, Selenium. So that is integration test cases, or the functionality test cases, or thus we have the load testing purpose, the load runners. So that is on the base of this, the types of the testing. So different testing tools they use it, and unit testing point of view, there's a JUnit for the Java programs. So there are like some testing tools required to integrate in the process. And then yes, we are saying this, we need to do the automation. Means we need to write it some scripting. We are not the programmers. Programming level not that much required, at least scripting level required. But what are the different scripting tools which are available in the market? The shell scripting, Perl scripting, Python, PowerShell, that is for the Windows-based scripting, Ruby. So there are the different scripting tools are available in the market, which we deal with that shell scripting. And some of the Ansible point of view, the Python, we deal with that. Yeah, so this is like the scripting is required in the process. So everything is not possible, but at least from each section point of view, at least some tools require at least one tool is required to understand it. But as per the project and the type of technology, these tools are going to change it. But if you're going to mention this in the resumes, or if you're going to like say this, I know the DevOps engineer. So each section point of view, like at least one of the tool which we should know that. And yes, monitoring tools has continuous monitoring, continuous testing, that is Selenium or JUnit, continuous monitoring, that is which we have the Nagios, we are going to deal with that, but we have so many tools in the market, but the Nagios which we deal with that. And the cloud points of this, the cloud related monitoring tools, we talk it that. Yes. The next one more generation of this, the technology which is available is the container orchestration engine. Is that means the container based applications or the tools, that is the COEs which are supporting that. The COE is like a container orchestration engine. So the Docker or the Kubernetes or the Swarm. So we are going to talk about the Docker and Kubernetes. So at least we are going to talk about this like almost 10 to 12 classes on the Docker and Kubernetes. This is the next generation of this the technology, but we talk it the more whenever we discuss that's the why it is going to change that, or what is the need of this Docker and Kubernetes. Yeah, that's we'll come back to this on the Docker and Kubernetes. And yes, the cloud, yes, which we should know that all these activities to work on this, the cloud infrastructures, like we have this Amazon or the Google Cloud or Microsoft Azure. So at least one cloud which we need to add it as a DevOps engineer, which we deal with that AWS here, Amazon. And yes, yeah, any issues which are happening as an operations engineer point of view, you need to keep on track about your there's the issues. So what are the issues are still pending, or what are the issue statuses? That's to track it, the issues. Yes, the Jira is another important tool. The process point of view, the Jira ticketing tool, which we should know some points on that. And yes, virtualization software like VMwares, how to manage it as infrastructure wise. Whenever we talk about that, some virtualization softwares that's required to understand it, like the virtual box or the VMware, the Vagrant. We are going to deal with the virtual box and the Vagrant in this process. These are all on-premises virtualization systems to manage it. And this is Amazon, which is supporting the cloud-wise virtual machines to manage it that. So on-premises, the virtualization, and as well as the cloud. Also, we talked about that EC2 instances in the cloud. So how that is supporting about it. Yeah, so there are all the tools so required to understand. So on the virtual box, one class we have, a Vagrant like two classes we have, Jira one class, on the AWS around like 7 or 8 classes. We are going to deal that some important services from that. On the Docker and Kubernetes around 10 to 12 classes required. The Nagios is 2 or 3 classes. And shell scripting around 5 or 6 classes we are going to talk it here. The JUnit point of view, this one class around. The Tomcat is separate 1 or 2 classes we are going to talk it to understand this, the application servers. the Ansible around 7 or 8 classes, the Puppet 3 or 4 classes, the Linux point of view like around the 6 or 7 classes to understand this, the Linux platforms, and the Jenkins around 8 to 9 classes, then Nexus 1 class, the Sonar or the Ant. So these are all the tools that is required. So that's why we have this the course content which is required around 2 to 2.5 months in the process. Yeah, so that's about the topics which we are going to deal with. That now you got the clarity about it, what is the DevOps, and so why we have these tools and what is the need of these tools. Yeah, so if we just having any queries, please let me know that.
Hello. Hello.
Hello. Yeah, Sai.
Yeah, hi Venkat.
Yeah, hi. Yeah,
Yeah,
please go ahead.
are you going to means explain via any project, means, taking any